So today we're in section 11.7, combinations. And with combinations, we are looking again at total number of possibilities or outcomes or selections based on a total and how much of that total is selected, just like we did with permutations. All right. So let's go ahead and look. Now we're going to skip over to example 2, counting combinations. Let's look at this example. It says you need to write 4 book reports for your English class. Your teacher gives the class a list of 7 books from which to choose. How many different groups of 4 books can you choose from the list? Well, it doesn't say anything specifically about order here. It just says you have a list of 7 possible books and you're going to choose 4. So because it doesn't specifically say anything about order, that's how I know it's a combination. And so here's my formula. NCR equals, so to find the number of combinations here of book reports, I'm going to divide the number of permutations, which is going to be basically just copying that, except I'm finding permutations divided by the number of objects taken at a time, or the targeted number of objects. So here's how those substitutions are going to look. How many books did it say were in the list? 7 books in the list. That's my total. And how many books did they say we had to read? 4. So that equals a permutation of 7 and 4 divided by, remember, my targeted amount, and how many did I have to read?
4.
So a factorial of 4. And now I can put, really, I can put either one of these, and I kind of got to this a little later in the lesson with 6 hour, but if I can put either one of these in my calculator, it will produce the same exact answer. So obviously, the first one, 7C4, will be easier. Let's do that one first. So you're going to hit the number 7, shift and the division sign. That will produce your C for combination, and then a 4, and hit equals. And what is your total? 35, but what am I labeling? 35 what? Groups of books. See that last sentence? How many different groups of books? So groups of books. All right, that whole thing is your label. You need to make sure your label is detailed. Or, guys, right here, over this way. Come on. All right, so, or you can hit your fraction button. Hit the fraction button. And we're now going to enter this fraction. So you're going to do a 7, shift multiplication sign to produce your P, and a 4. Now go down into your denominator and hit a factorial of 4. So that's 4, shift, and then the x to the negative first, and hit equals. And what does it give you? Gives you 35 again. So either way of calculating is fine. On your homework, you have to show me both steps, the original and the substitutions, and then you can use your calculator, either one of those, to produce the correct answer. Any questions on that? You think you can do a couple of those? All right, so here we go. I want you to find the combination and think of it in terms of books still. 6C3. So now how many books did the teacher give you to choose from? How many do you have to read?
3.
All right, now what about this one? 8C5. Now how many books did she give you?
8.
And how many do you have to read?
5.
All right, and then the last one, 10C2. So find the total possible groups of books, okay, that you could read for each one. So let's look at our substitutions. Again, I divide the permutation, 6P3, divided by the factorial of my targeted amount. And what do I get for the first one? 20. All right, and then what about my second one? I go 8P5 divided by a factorial of 5, and what do I get? 56. And then on my third one, I have a permutation of 10 and 2 divided by a factorial of 2, and what do I get? 45. All right, anybody get all three of those right? Now, this is the work that I'm expecting you to show on the first section of your homework tonight. Speaking of homework, you don't have to do number 10 because that's example 1, and we skipped example 1. So it'll be numbers 12 through 32 even that you have for homework. All right, so now let's move on to the next slide. All right, now in example 3, and this is probably the most important part of your lesson, telling the difference between a permutation and a combination. And here's the key. What is that one word that differentiates them? I'm looking for the order. Is there any type of wording that says that order is important? If order is important, which one do I use? Permutation. If order doesn't matter, I can use a combination. So let's read the first one. There are 50 sculptures being exhibited at an art show. A Best in Show prize and, that should say and, a runner-up prize are awarded to the top 2 sculptors. How many different pairs of sculptors can receive the prize? Let's read the second example now. There are 50 students in the speech club. 3 of these students will be chosen to represent the school at a regional competition. How many different groups of 3 students can be chosen? One of these is a permutation and one is combination. I want you to answer it on your paper. What do you think on the first one, permutation or combination? It is a permutation. Someone gets a first place and someone gets a second place. Order is important here. Not everybody's a winner. And there is a selection process. Okay? So, yes, this is a permutation. Now, since it's a permutation, how could I set up my permutation? Obviously, I have a P. What number would go in front of the P? What's my total? 50. And what number would go after? A 2. So find the total number of groups or pairs that could be selected for this prize. So what's it going to be? What's it going to be? 2,450 potential pairs. Pairs of sculptors. Remember, we want to get specific here. Sculptors. Try to squeeze it in there. All right, 2,450 potential pairs of sculptors. All right, now let's look at the second one. 50 students in the speech club. What did you think? Combination or permutation? Obviously, this one's combination since it's one or the other. All right, and what would my combination be? What's my total? 50. C, and how many are selected? 3. And what's my total going to be?
19,650
Groups of students. All right, now this is what you're going to be doing on some of your homework questions tonight. You're going to be choosing permutation or combination, so that's your first answer. And then you're going to be telling me how many, what are the possible combinations. Any questions here? Now, I made up 2 more because I think that the scenarios are important so you can see multiple. And maybe it'll kind of help you see the difference. Now, here the difference is not so clear. We talked about it last hour. It's hard when you're trying to teach a clear difference, and they both look pretty much the same. Let's read them. There is a difference, though. There's 30 dogs in a dog show. Blue ribbons are awarded to the top 3 dogs. How many different groups of dogs can receive blue ribbons? Now look at the second one. There's 30 runners in a cross-country race. How many different groups of runners can finish first, second, and third? All right, so I want you to decide which one is the combination and which one's the permutation. This one, the difference is not so clear. So what do you think? First, what do you think about the first one? Permutation or combination?
Combination.
Why? That was such a definitive answer. Why? You're exactly right. They bring the dogs up to the front, and they all get the same blue ribbon. So we technically don't know which dog of the three is first, second, or third. They all just get the same blue ribbon. However, in the second one, there's clearly a first, second, and third. That's why that one's a permutation. That makes sense? Man, you guys, y'all caught that. The first one's a combination because they all get blue ribbons. Even though it's top three, they get the same blue ribbon, so there still is no order. All right, so this one's a combination. All right, since it's a combination, what's my total? 30. C, and groups of how many? 3. Okay, and I find my total. And then the next one's a permutation. And the permutation is 30P3. When we find both of the totals now, we can clearly see that there were a lot more permutations than combinations. All right, really with the same types of numbers. Okay, so but those are the different possibilities. Combinations and permutations. All right, any questions? Any questions here? Yes, so we do need to make sure we label. So this one would be groups of dogs. And then this one would be groups of runners. Runners. Okay. Yeah, sorry. I know, one too many. Okay, runners. There we go. All right, so that's how we find whether or not it's a permutation or a combination. The last example we need to talk about is finding probability. You have 10 marbles in a bag. Each marble is a different color, including red, blue, and green. Draw 3 marbles at random. Find the probability that you draw a red, blue, and green marble on one draw. So the first thing you need to do is find the total number of possibilities. And then, honestly, guys, one draw, favorable outcome, your numerator is going to be 1. You're basically just turning it into probability. Okay, 10 marbles in a bag. All right, so here combination is important. All right, so 10. Okay. Combinations, and what am I talking about? Probability. I'm finding probability. So 10, I start with 10, and I'm only selecting 3. So what's the total number? 120. And the odds that I select that combination is 1 over 120. All right, so over here I have 12. See, and how many am I choosing? 2. Okay, so what's my total number of possibilities? 66, and it's 1 over 66. All right, and that's how you would find probability using combinations. Okay, and that's it. So that's everything you need to know for 11.7.